Please title these notes Derivatives 15 Notes, Strange Chain Rule, and write today's date.
By the end of this lecture, you should be able to apply the chain rule and the other rules you've learned in ways that are a little more abstract than what we've done so far. So let's write out a little table, and then we'll look at some kind of more general applications of the rules that we've learned. So let's say we've got some number x. This is the column for f of x, f prime of x, g of x, and g prime of x. So what we're going to say is that when x equals 0, these have just been calculated. We don't know where they came from. We just know that a number has been come up with. When x is 0, f of 0 is -1, f prime of 0 is 3, g of 0 is 6, and g prime of 0 is 2. Just, we know those. When x is 1, f of 1 is 1, f prime of 1 is -2, g of 1 is 0, and g prime of 1 is -3. So when x equals 1, the derivative of g, slope of the tangent line, when x equals 1, is equal to -3. We're just kind of told those. So let's look at a problem like this. Let's say that we have some function h of x. And we don't know a whole lot about h of x, but we do know that it's equal to f of x times g of x. We know that about it. And what we want to do is we want to find the derivative of h when x is 0. Now, we don't know what f of x and g of x are. They could be cosine, they could be x squared, they could be something else entirely different. So we can't use our normal rules, like, power rule, bring down the exponent, subtract 1 from the exponent, all that kind of thing. But we do know that when we get the derivative of f, if we put 0 in for it, we have this number. If we put 1 in for it, we have that number. So what we have to do is to try to sort of skip over the steps that we would normally do and just work with what we know. So let's start off by figuring out, in general, we're looking at the derivative. So in general, what would the derivative of h of x be? Well, these are two things multiplied together. So we're going to use our quotient rule, f prime g plus fg prime. But because we don't know what f and g are, I'm just going to write them out in their general form. The derivative of x, whatever that is, times g of x, plus f of x times the derivative of g of x, whatever those functions are. We don't know what they are, but we do know that if we put 0 in for x, we're told what f prime is when x is 0, right here. So in this case, the fact that we don't know exactly what f and g are doesn't end up causing a problem, as long as we're creative about it, because we know what the numbers are and we can get a number at the end. So here, when x is 0, f prime of 0 is 3, g prime of 0 is 6, f of 0 is -1, g prime of 0 is 2. That's 18 minus 2, h prime of 0 is 16. Ta-da! We can find the 0 is 16. Ta-da! We can find the answer even if we don't have those equations. Let's look at another couple examples of that. Let's say we've got an equation j of x, and that's equal to 3 times f of x plus 2, all of that times f of g of x. And we want to find j prime of 1. Here we see two things multiplied together, so we know that we're going to have to use the product rule. So we're going to take the derivative of 3f of x plus 2 times f of g of x, and then we're going to add 3f of x plus 2, and then the derivative of f of g of x. Same kind of stuff we dealt with before, except now we don't know what f and g are. We just kind of have to work with them in general. The derivative of j. Well, I'm looking at this, and this f of x is just something. I don't know exactly what it is, but I do know that this 3 is along for the ride, and I'm going to take the derivative of whatever f of x is. Derivative of 2 is just 0, so nothing else. And then this f of g of x is going to stay along for the ride. Here, same thing, 3 times f of x plus 2. And now I'm going to take the derivative of f of g of x. Here's where we have to remember something about the chain rule. This is the formal statement of the chain rule. It didn't make a whole lot of sense when we went past it the first time. But what we say with this is we say that the derivative of f of g of x is the derivative of the outside function, and then just substitute in the inside function, times the derivative of the inside function. That's the rule that we're going to have to use now. We're going to have to say that whatever is inside here, we're going to take the derivative of the outside function, that f, and then put in whatever's inside, and then we're going to take the derivative of that inside function. We're going to see what this means in terms of the numbers in just a second. So we've got this. We're going to come back up here and look up here and see what we can put in. Let's see, we're doing j prime of 1. So when x is 1, if I look up here, f prime of 1 is negative 2. So I'm just going to put that in. And when I get to this one, it's a little bit different. We've got f of g of x. I'm going to do its inside first, so this f is still along for the ride, but I know that when x is 1, g of 1 is 0. Now, this f of 0, that just means what's f when x is 0, and we'll be able to look that up in the table. Before we get there, though, let's do these other pieces. We've got 3, and then when x is 1, f was also 1, plus 2. Here we've got the same thing that we saw over here. We're going to do the inside piece first. We've got f prime of, and then we said when x is 1, g is 0. And then when x is 1, g prime was negative 3. Let's go back and fill in these last two. So we've got 3 times negative 2 is negative 6. When x was 0, f of x was negative 1. 3 times 1 is 3, plus 2 is 5. F prime of 0 was 3. And there was a negative 3. Right there. When we put that all together, j prime of 1 was 6 minus 45, or negative 39. Let's look at a third one. Let's say we know that k of x is 2 times f of x over 3. And we want to find the derivative of k when x is 3. First thing we need to do is find the derivative of k of x. So we know that this 2 is just along for the ride. Here we see a chain rule again. We have an outside function, the f, and the inside function, the x over 3. So I'm just going to put a little box around this to remind me of what's going on. And I know that I'm going to take the derivative of the outside function and leave the inside function the same. And then I'm going to take the derivative of x over 3. One thing that would be helpful to notice for this is that this is the same as 1/3 times x. So when I'm taking the derivative here, the derivative of 1/3 x is just 1/3. Now I'm going to put this 3 in for x and see what happens. Well, I know that 3 over 3 is just 1, so k prime of 3 is 2 times f prime of 1 times 1/3. I know if I go up here when x is 1, f prime of 1 is negative 2. So I've got 2 times negative 2 times 1/3. Or negative 4/3. Let's give you a check for understanding problem. If m of x equals 2 f of x over 2 plus 1, and all that times f of g of x over 2, find the derivative of m when x equals 2. Try that one on your own. Restart the video when you're ready. Pause the video now. First thing to notice is that there's a product rule going on here, so the derivative of m of x means that we're going to first need to take the derivative of 2f of x over 2 plus 1. We also see there's going to be some chain rules in here. So with the derivative of this, the 2 is along for the ride. We're going to take the derivative of f. We notice that this is needs to be in a box because it's not just an x. So that means we're also going to have to do times the derivative of x over 2. Derivative of plus 1 is just 0, so that can go away. Here we're going to have f of g of x over 2. This is along for the ride. And then this, we're just going to keep taking the derivative. So the derivative of the outside function, f of g of x over 2. Then we've got to take the derivative of the inside, g prime of x over 2. And then the derivative of the last inside function, derivative of x over 2. Oops, lost room there. That's the derivative of x over 2. We're taking that last piece. So we're got to do those two derivative pieces. Remember, x over 2 is the same as 1/2 x. So the derivative of x over 2 is just 1/2. So we've got 2 derivative of x over 2, excuse me, a derivative of derivative of f of x over 2 and then this derivative of x over 2 just becomes 1/2. Next piece is along for the ride. Along for the ride. And then the derivative of x over 2 is just 1/2. Okay, let's start putting some numbers in. We know that x equals 2, so we can just put that in wherever we see an x. So m prime of 2 is going to be 2 times f prime of 2 divided by 2, or 1, times 1/2. Here we're looking at f of g of 2 divided by 2 is 1, plus 2, and then f of 2 divided by 2 is 1, plus 1. We've got f prime of g of 2 divided by 2 is 1, times g prime of 2 divided by 2 is 1, times 1/2. Now we're going to come back over here and look up each of these numbers. We're looking in this column right here, this row right here. So m prime of 2, f prime of 1 right there is -2. I'm going to take out that f prime of 1 and write -2. Multiply by 1/2. Now we're going to do f of g of 1. G of 1 is 0. F of 1 was 1. We've got f prime, g of 1 was 0. G prime of 1 was -3, and then times 1/2. Almost there, we just have to substitute for these f ofs. I can also see that those cancel out while I'm at it. So we've got -2. F of 0 was -1, plus 2 times 1 is 2, plus 1 is 3. F prime of 0, if I look at the table, was also 3. I've got a -3 right here, times 1/2. Almost there, m prime of 2 gives us 2, and then this is -27/2. So that is 4/2 minus 27/2, or -23/2. Okay, let's move on to another type of strange thing that you might see. I'll label this other strangeness. Let's say we have a function q of x, and q of x equals 3x squared minus 2x plus 4. And we want to find the derivative of q of 3x. There are two ways to think about this. One is to just use the chain rule. So we're going to say that the derivative of q of 3x is just the derivative of the outside, whoops, that's a q, leave the inside untouched, times the derivative of what's inside. So what this one's saying is it's saying that basically these are just little boxes, this x. And what we're going to do is we're going to take the derivative up here with the boxes. So we bring down the 2, so that's 6 box minus 2. And then all of that is times the derivative of 3x, which is 3. Now, what goes in this box is what's inside here. And then we're just going to simplify that. So 6 times 3x is 18x minus 2. Times 3, we'll distribute that 3 back over. 54x minus 6. The other way to do this is to say that q of 3x just means that we're taking 3x and we're sticking it in for each of the x's. So q of 3x is 3 times 3x squared minus 2 times 3x plus 4. If I square this, that's 3 times 9x squared minus 6x plus 4, 27x squared minus 6x plus 4. And now when I do the derivative, I bring down the 2, that's 54x minus 6. Same answer. Either way you want to think about it is fine. Sometimes one way will be easier, sometimes the other. We will definitely get the same answer either way, as we'll notice when we see this one. This is our last example problem, and then you'll do a check for understanding. So let's say we've got a function p of x, and that equals 2x squared plus 5x. We want to find the derivative of p of the cosine of x. So one way to do that is to say that the derivative of p of the cosine of x is p prime of cosine of x times the derivative of the cosine of x. And what that would say is just that we're treating what's up here as if it were a box. We're going to take the derivative and we're going to stick the cosine of x in the box. So that means we would have 4 box plus 5. Inside that box is the cosine of x. And the derivative of cosine of x is simply negative sine of x. So our answer would simply be negative sine of x times 4 cosine x plus 5. If we did it the other way, then the first thing we would do is we would say that p of cosine of x equals 2 cosine x squared plus 5 times the cosine of x. And then when we take the derivative, what we would do is we would just be doing that chain rule. So here we've got our box. So we're going to bring that down. 4 cosine of x times the derivative of what's inside, so negative sine of x. And then we're going to take the derivative right over here, so that's 5 negative sine of x. Now, one of the things to notice is that we've got a negative sine of x here, we've got a negative sine of x here. We can factor that out. Ends up with exactly the same thing in both cases. Okay, let's have you try a final one on your own. If t of x equals 6 minus x squared, find the derivative of t of 1 over x. Try that one on your own. Restart the video when you're ready. Pause the video now. Okay, let's do it this way. Let's do the derivative of t of 1 over x by doing t prime of 1 over x times the derivative of 1 over x. And I'm going to write that as the derivative of x to the negative first power, just because that makes life easier for me. So I notice that I've got a box right here around that x. So the derivative of 6 is 0. Bring down the 2, negative 2, whatever's in the box. And that is 1 over x. And then we're going to do times the derivative of x to the negative 1. So we'll bring down the negative 1, subtract 1 from the exponent, and let's see what we get. So negative 1 times negative 2 is 2. That's all over x. This x is in the denominator, so we have 1 over x squared, 2 over x to the third. That concludes derivatives 11 notes.